Hey everyone, Mr. Skelton here. We are back at it. We're going to start lesson 5 today in Unit 4, and today we're going to be talking about something called synthetic division. Synthetic division is something that is used in addition to long division. You did long division in lesson 4, synthetic division here in lesson 5. Most students tend to stick with synthetic division. That's a little bit quicker and still generates exactly what you would get if you were using long division. But it is important to remember how to use long division. I will require that of you on quizzes, tests in the future. We're also going to learn about the remainder theorem. The remainder theorem is something that's pretty short and sweet. There's not a ton of application to it, and so I'm not going to spend a lot of time on it, but the most important thing today for you is to be able to walk out of this notes understanding how to properly use synthetic division. So we have this problem here, this basic division problem, and we're going to review first by doing long division. So if you remember from long division, we always want to check to see that we have the highest degree to the smallest degree, and then if there's any missing degree numbers, that we plug in a 0x or a 0x squared or whatever the degree that's missing into our problem. I have x cubed, x squared, x in a constant, so I'm good, and I'm taking x minus 3, so I have 5x to the third minus 6x squared plus 4x minus 1. So let's take a look at this using long division. Let's review. So what times x gives you 5x cubed? That would be 5x squared. And so 5x squared times x would give me 5x to the third. 5x squared times a negative 3 would be a negative 15x squared. I subtract those. I always run my negative sign through and change the sign and add them. So those cancel out. 15x squared and negative 6x would give you a 9x squared. And I bring down my next term, which is a positive 4x. Rinse, wash, and repeat. X times what gives you 9x squared? That would be a 9x. So 9x times x is 9x squared. 9x times negative 3 is a minus 27x. Again, I subtract those, so I run my negative sign through and add. Those cancel out. There's an add sign there, so I get 31x. Drop down my negative 1. I have what times x gives you 31x. That would be a positive 31. So 31 times x is 31x. 31 times negative 3 would be a negative, what is that, 93? Is that right? I believe so. Double check it here. And then I have subtraction, run it through, add it. So that's going to be a 92. And this is my remainder. There's nothing to bring down, and so I have 92 as my remainder. So I would write remainder 92, and this would be my answer right here. And so that's using long division. What I'm going to do with you next is show you the point of this lesson, which is what we call synthetic division. Now, synthetic division is kind of like I wouldn't say it's a formula, because it's not a formula, but it's definitely something that you kind of have to put to memory. And here's how you do it. You're going to use the coefficients of each term and kind of write them in a line. So you have 5, you have negative 6, you have positive 4, and you have negative 1. And just like before, if you had any missing numbers, any missing degree numbers, you'd plug a 0. So we go 5, negative 6, 4, and negative 1. And we write them right in order. Okay? Make a little L here, okay? And then right outside the L, you're going to put the 0 of what you're dividing. So this is in factored form. What would be the 0 of that factored form? It'd just be a regular 3, right? If you set that equal to 0. And so you're just going to put a 3 right there. Okay? It's always the 0 of the factored form. Now here it's kind of a routine. The first thing you do is you're going to drop down your first term, which is a 5. This is a combination of multiplication and adding. You're going to multiply these two together to get 15, and then you add your two numbers. Okay, so that would be a 9. And then you multiply 27, you add 31, you multiply again, and you get, let's see, 93, and then you add, and you get 92. Now, one thing that's important to remember, and I usually do this in the beginning, but I kind of left it to the end to explain it to you. I usually draw a little squiggly line in between my second to last and last number, because the last number listed is always your remainder. Okay? And then you can kind of see where we're going here with our answer, because this works like this. The next digit over from your remainder is always your constant, and then this is always your x value, and this would be your x squared. And it always keeps going. So if you had like 5 numbers here, it'd be constant x, x squared, x cubed, x fourth, x fifth. And so this just becomes 5x squared, because these represent your coefficients. This would be plus 9x. This would be your constant, so just plus 31 with a remainder of 92. And you can see that you have the same exact answer using long division as you did synthetic division. It's going to take you some practice. You may need to watch this video again. Now, what's important here? I want you to understand what this means when you have a remainder, because I think some students miss this. What does it mean when you have a remainder other than 0? That means that 3 is not a 0. If it was a 0, you would have a remainder of 0. Okay? So x minus 3 is not a factor. It does not divide evenly because you have a remainder. That's important to know moving forward. So a lot of students, when we do this, they kind of get locked into the process or the algorithm of how to do this. But remember that the most important thing is you're testing to see if x minus 3 can go into this polynomial evenly. If it can't, that means you have a remainder. That means 3 is not a 0. Okay? All right, let's go over to the back side here and apply this a couple more times so you can see this. So here's a situation. We have the volume of a rectangular, I don't even know what that is, sarcophagus? Sarcophagus? I don't even know what that is. I assume it has something to do with the tomb there. But it can be expressed by the following function. Volume, x cubed minus 13x plus 12. If the length is x plus 4, okay, so the length is x plus 4, what are the other dimensions? So we have to find the width and the height, all right? So here's a situation where basically we're taking the volume and we want to divide it by x plus 4. And so we're going to use synthetic division here. So again, if this is the factor, that means negative 4 would be the 0. Make your L. So what's the coefficient here? That would be a 1. Now notice I don't have x squared, so I plug in a 0 for 0. It's really taking the place of 0x squared, and then a minus 13, and then a 12, and I do a squiggly line because this box right here is your remainder. Okay? So synthetic division, you always drop down the first number, 1, you multiply, which is negative 4, add to get negative 4, multiply again, you get positive 16, add those together, you get 3. Negative 4 times 3 is negative 12. Add those together and you get 0. Awesome. So what does that mean? That means that negative 4 is a 0, or x plus 4 is a factor. Now we know x plus 4 is a factor because it tells us that. It says if the length is this, find the other dimensions. So we know x plus 4 is a factor, which means that x equaling negative 4 is a 0. But look what we have left over. Remainder 0. This is your constant. This is your x. This is x squared. So this can be written as x squared minus 4x plus 3. Now when you do synthetic division, you always want, and we want to find the other factors here, what you have left over, always check to see if it can be factored, which it can. What two numbers multiply together give you positive 3, add together you get negative 4. That'd be a minus 1 and a negative 3, right? Negative 1 times negative 3 is positive 3. Negative 1 and a minus 3 make a minus 4. So you have an x minus 1 and an x minus 3. Now it doesn't say which is which. We're kind of giving you a little different scenario here. But this is what we have. It says if the actual length is 10 feet, what are the actual other dimensions? So if the actual length is 10, so we'd go 10 equals x plus 4, so we would subtract 4, and we get x equals 6, so we'd get 6 for x, which means the width would be 6 minus 1, which would be 5, and then the height would be 6 minus 3, which would be 3. And so those are the other dimensions. Okay? So we have 10 by 5 by 3. Down here, Pan, Man, the magician. Okay? Suppose you have f of x equals x to the 4th minus 5x squared plus 4x plus 12. It says, can you find f of negative 4? Now, what this is a little bit different, right? Because we're used to saying something like this. Is x plus 4 a factor of this? And we would use synthetic division. But they can ask it to you in another way. They can just say, hey, test to see if negative 4 is the 0, right? Because what does f of negative 4 mean? That's usually f of x. So they're essentially saying, hey, x is negative 4. And it says, can you find it? So you're probably thinking, well, Mr. Skelton, can I just plug in, a negative 4 here for x, here for x, here for x, and just figure out the answer? The answer is yes. You can do that, okay? But I want to show you, this is the remainder theorem. This is kind of what we talked about at the beginning. This is not really important in terms of how to, what the remainder theorem is or does, but I wanted to show this to you just so you can kind of maybe get a bigger picture of what's happening here. So we're going to test this with synthetic division. So again, they're giving me the negative 4, so they're giving me the 0 there, and then I'm going to go a 1. I don't have an x to the 3rd, so I got to plug in a 0, and then I have a negative 5, and then a 4, and then a 12, and I always squiggly line for my remainder box. Drop down, 1, negative 4, add them, negative 4 times them, 16. That should give me 11, negative 44. That should give me negative 40. And I have 40 and 4. And 40 and 4 is going to give me 160. And I will add those to get 172. Okay? Now, this is your remainder. Okay? And what I want you to know is if you plug in negative 4, I'm going to show you what this looks like. So if I take negative 4 to the 4th power, so negative 4 raised to the 4th, that's going to give you 256. So I'm going to kind of just show you this 256. Okay? And then I have negative 4 squared, which would be 16, right? 16 times negative 5. That's going to give me minus 80. Okay, plus 4, that's got a negative 16 when I plug in negative 4 for x, and then plus 12. So watch what happens. You get 256, we're going to subtract 80, we're going to subtract 16, and we're going to add 12, and look what you get. You get 172. Now I told you that you could just plug in the negative 4 for x and get 172. This is called the remainder theorem. Basically what it is when you do synthetic division, your remainder is going to be equal to the same number as if you were just to put the 0 in for x. Okay? Why do we do this? Well, we do this because we want to make sure that we can always test points. We're going to do this in a couple other lessons down the road. And so we could just make some guesses and say, oh, I want to check negative 4 to see if it's a 0. If you get a remainder, it's not a 0, which is the most important thing. Okay? And so again, it's not a big deal, but I just wanted you to know that this is called the remainder theorem, and it happens when you do synthetic division and you get a remainder. It's the same thing as if you were to plug this negative 4 in for the x's, you would get the same exact thing. Okay? So we'll probably do a couple more in class just together for synthetic division, especially synthetic division, so you get good with this routine. But it's very useful, and a lot of students, will prefer using synthetic division over long division. A lot less errors to be made in synthetic division as opposed to long division. But they both get you to the same spot. Okay? Look forward to seeing you in class.